A very good morning, children. In yesterday's session, we learned the introduction about the thermodynamics chapter and some of the fundamentals in this chapter. And now we are extending the continuity part of this second session, that is the lesson number 2. This lecture number 2, we are going to see the remaining parts of this chapter. Do you remember what is the internal energy was represented yesterday? Yeah, delta U. The change in internal energy is the delta U, is the representation we had learned. For example, let us see, on this earth, now we are using gas stoves. But before this gas stoves, people used to take the help of the sticks that they used to cut the forest to heat something. Means when the stick is burning, it is passing its energy and making the food to be cooked. Means the energy is transformed from one form into another. Or in a simple manner, nowadays you can see, we are converting the solar energy into heat of the water, solar water heater. Is it not? We are converting the energy from one form to another. But we cannot create new energy, or we cannot destroy the existing energy. That's what the first law of thermodynamics speaking. What the first law of thermodynamics says is that energy can be created nor destroyed. The energy in this universe cannot be created nor destroyed. That is the sum of the heat content and the work done. That is what they are given in the form of the equation. Delta U is equal to Q plus W. Means the change in internal energy depends upon the heat and the work done. So what the first law of thermodynamics saying? Energy can be created nor destroyed, but it can be transformed from one form to another form. Very important small equation. Because this small equation delta U is equal to Q plus W is going to bring the complete explanations for the questions that will be raised. And now there are 3 questions for us. To solve this is what the important concept. And yesterday we had learned one more thing. Whenever heat is absorbed by the system. How to give it to them? It is given in the form of positive. Whenever heat is removed from the system, how to give? Then they give in the form of the negative. Whenever something comes into the system, positive. When something goes out of the system, negative. This is what the small point of number. Not only that, in the case of W, when work is done on the system, positive value. When work is done by the system, we need to give a negative value. This is the concept that we had learned in the yesterday's session. Right. And we had also learned one of the small topic, adiabatic process. When the heat does not get in or out of the system, but there is a change in temperature, is called as the adiabatic process. So these are the points that we have learned yesterday class. Now we are continuing the question that is going to be in the first one. Question number 1. For that the concept is given as express the change in internal energy. Change in internal energy delta U. Change in internal energy of a system when no heat is absorbed by the system from the surroundings. When no heat is absorbed or evolved by the system or from the surroundings, we say it is an adiabatic process. You don't remember. But work is done on the system. How is the work done? Work is done on the system. When work is done on the system, what value will be? It will be positive value. Just speaking with internal energy change. Now see here the key concepts what you must not forget. There is no heat is absorbed. Like means the Q becomes 0. What is one for heat? Q. So the change in internal energy, anyhow the Q becomes 0, but work is done on the system. Work is done on the system. So how can we give? We can give delta U is equal to W of adiabatic process. Because what is an adiabatic process? Where there is no exchange of heat between the system and the surroundings is called an adiabatic process. What type of wall does the system have? The system is having what kind of wall they are asking. See here, heat is not getting in or out. So what is a ball first of all. If we take a test tube, in the test tube we will conduct the reaction. The test tube, the glass is called as the wall of the system. This is called as the wall of the system. So they are asking what type of wall they have. They have in this case the adiabatic wall. What is the type of the wall they will have, children? The wall is the adiabatic wall. The wall is the adiabatic wall. Right? We are going for second question. No work is done on the system. No work is done on the system, but Q amount of heat is taken out from the system. Q is evolved. What is evolved now? Q is evolved. Heat is evolved from the system and given to the surroundings. What type of wall does the system have? Heat is given out, means it is conducting the heat. It is conducting the heat. As you remember, the tea glass, when I hold it, it's somewhat hard because it is a good conductor. So how to give the change in internal energy now? Generally we know change in internal energy is equal to Q plus W. But here work is no work is done. Here W is becoming 0. So we can speak generally delta U is equal to Q. But Q amount of heat is taken out from the system. So we need to say work is not done. So what is W value? W became 0. W became 0. So we say delta U is equal to minus Q because heat is given out of the system. What type of wall does the system have? It is conducting heat to the surroundings. So wall is conducting wall. What is the type of the wall, children? Wall is a conducting wall. They are conducting walls. Question number C. W amount of work is done by the system. So W amount of work is done by the system means by the system means compulsory will be negative. Q amount of heat is supplied to the system means absorbed. Q amount is absorbed. W is taken. Give the internal energy expression. So delta U is equal to generally what we know Q plus W. What about the heat? Heat is supplied to the system. Heat is supplied is absorbed means it is already a positive value. W amount of work is done by the system. It is given by the system means we can say internal energy is equal to Q minus W. Very simple thing. These 4 points you must keep in mind. Q means heat when absorbed, positive value. When evolved, negative value. Work done on the system, positive. Work is done by the system, negative. Very simple. Write down these points. We will continue our concept. See, children, during any chemical reaction, when the temperature is constant, what is constant? Temperature is constant. Such kind of process we call as the isothermal process. What do we call such kind of process as the isothermal process? See the definition here. A process that takes place at constant temperature. A process that takes place at constant temperature is called as an isothermal process. Very simple definition. I don't want much. Now a small explanation I would like to say regarding 2 simple terms. Now imagine I am now in the ground floor. I want to go for the first floor. Where do I want to go for the first floor? There are 2 methods. I want to climb up the steps one by one. One by one step I want to climb up. Now when I am going forward, 1 step, 2nd step, 3rd step, 4th step, 5th step, 6th step, it is having 13 steps, imagine. So after completing all the 13 steps I am going for the first floor. Is it not? Now for example, after reaching to the 7th step, I got a thought that I would like to come back to the ground floor. So slowly, step by step down, I can come to the ground floor. Is it not? How do I will go? I am going slowly, step by step up. Similarly, step by step down, I can come very slowly. So this process in which we can do any step either forward very slowly or either backward the same slowly. But here I am not climbing to the first floor in a single step. I am taking the small steps. It is called infinitesimally. So any process which you are doing step by step very slowly, and it can be reversed very slowly. We call as a reversible process. What do we call as a reversible process? I am giving the definition of a process which is carried out infinitesimally slowly, means in a slow step manner, infinitesimally slowly, such that it can be reversed. It can be reversed at any instant of time by reversing the driving force infinitesimally. Means I am going, what's the driving force? My energy is for the driving force is not. When I am going step by step forward, I can come back again during this reversible process. But now you are using, what are you using? Escalator. What are you using? Escalator. Do you remember what's the name of escalator? There will be steps here. For the escalator, there will be steps, and these steps will be placed on a platform or a chain. The chain, you just need to step on one step. It will go forward. Is it not? Go. But the problem is, even though if you are trying to step down, it is going forward. Can you come in a reverse form? You cannot come in a reverse form. Means you cannot reverse the reaction. Escalator is going up. Even you are trying to come down, it is going up again. So you cannot reverse the process. Such kind of process what we call as a reversible process. The definition is a repeated process which cannot be reversed at any instant of time by reversing the driving force in small amount is called as an irreversible process. See children, we had already learned about these terms, but a small type of question is given. So in order to explain the question, we are giving these terms. What the term means? Different types of energy changes in the modern systems. We already know the internal energy is equal to Q plus W. What is that Q and what is the W? Q is the change in the temperature difference. The change in the temperature is difference is nothing but the change of heat. The change of heat means the Q, the heat depends upon the change in temperature. Obviously, Q is directly proportional to the change in the temperature. We already brought the word. What is the word we got? When heat is leaving from the system to the surroundings. When the heat system to the surroundings is transformed, Q is given in the form of negative. When heat is given to the system from the surroundings, we can say it is the positive, because some children are still having a doubt. What is this Q? Q means the change in the heat content. It depends upon the change in the temperature. Then what is the work done? The W. Exchange of energy between the system and surroundings can occur in the form of work. So which may be either mechanical work or the electrical work. Some children did not got these definitions. What is meant by work and what is meant by the heat change. So these are the small definitions for the work and the heat change. Write down these two definitions, children. We are taking one important concept now. We are now having a glance at the very important concept in the basics of the thermodynamics. Already we learned what is called as a reversible process and what is called as an irreversible process. So here we are deriving one expression for mechanical work done in an isothermal irreversible compression of an ideal gas. It is an irreversible compression. It means after you compress, it is not getting back into the normal state. You know the syringe injection, children? Yes, the injection will have one cylinder and will be provided with a piston. We will move the piston forward. Is it not? Now imagine in the injection there is no liquid, but there is some ideal gas. We know much about ideal gas. It follows PV is equal to nRT. It's called as an ideal gas. In that case, we are seeing, we left at this point. Sorry for the interruption, children. What is an ideal gas? Ideal gas, we know that follows PV is equal to nRT. Now in imagination, we have taken one syringe. In that we had filled the gas, ideal gas, and this is the piston. That is as VI is the initial volume of the piston. And now after applying this external pressure, means it is not done at a time. We need to go very slow in process. After because generally gases can be compressed, no, so we are taking gases but not, we cannot take liquids as they cannot be compressed. Now our concept is we are compressing the gas. This is the final volume up to where you can compress. How you are able to compress? You are able to compress by giving a pressure from the external. That's what we call as an external pressure. Now we are bringing our derivation how to give the work done for the irreversible compression of an ideal gas. Even you are compressing, it is not getting back, so it's called as an irreversible compression for an ideal gas. We know generally volume change. How to give a change in volume delta V? The depends upon length and the cross-sectional area. What is the length? This is the length that you had compressed up to now. You had compressed up to now. This is the length. From initial to final that you had compressed is called as the length. Area, the area of the gas that is occupying in this area. So it's the product. The change in volume is the product of length and the cross-sectional area. That's called A. But what is the definition we know about pressure? Because here what we are applying the pressure. You know pressure is the definition for force per unit area. Force per unit area. Why to bring this word means we are going to derive an expression for mechanical work. What is the definition for work? In the first year already we are introduced with. Work is equal to force into distance. Force into distance. In order to derive what is meant by the force, we are bringing this definition. What is the pressure? Pressure is equal to force per unit area. So we can write force is equal to pressure into area. Pressure into area. This pressure I am calling as the external pressure, and area is the capital A. So work is equal to force into distance we can know. But what is force? Force is equal to pressure into area. What is the pressure? Pressure expression we have brought. It is the external pressure. What is the area? Area is the A. How much distance is the gas being compressed? Gas has been compressed with the distance of small l. Small l. But now we can write now this equation as P into A into L. Means the change in volume. It is nothing but the change in the volume. Since we know change in volume is equal to A into L. But observe that what is the VI? VI is the initial volume. VI is the initial volume. What is VF? Final volume of the gas, of the ideal gas. Here the starting volume of the ideal gas is more in the initial stage, but after compression the volume of the ideal gas is less. So whenever the volume of final is less than volume of initial, volume of final is less than the volume of initial, we say the change in volume is given in the form of negative. I am repeating once again. When the final volume is less than the initial volume of the gas, the change in volume will be a negative value. So here, since final volume is very less than the initial volume we are giving, P external means external pressure is equal to delta V, negative delta V. Why did we put negative delta V? Final volume is less than the initial volume. Or I can write this equation as negative of P external into delta V. Delta V. So the work done can be given in this method or in one more method also we can. W is equal to negative of V external into delta V. What is delta V? Change in the volume. What the change in volume you have? Initial volume, generally we bring final minus initial. Generally change in volume, we give as the V2 minus V1. Explanation, do you remember? Change in volume is equal to final volume minus initial volume. So we can write this one as the change in final volume minus initial volume. So this is the expression for the work done in ideal gas. In the next video we will see the work done for the reversible compression of the gas. Thank you children. Have a nice day. Practice this derivation.